Well, hello everybody. I hope you're doing well in your isolation. For those of you out there working, thank you for doing your part to keep our economy going. I would like to take a few minutes to go over the front page of our Torque and Simple Machines packet. We did some of this in class before the whole new normal started, but we'll do a quick review of it again just to make sure everybody has the same notes and you can get your online packet updated if you are using it. So if you look at the front page of your packet, Torque and Simple Machines, I've created this homework packet, which dropped all the labs and it's just the practice homework problems. We will be sending out a packet with some modified labs later next week. So our first thing here is this tau symbol shown right there. Tau stands for torque. So here in our first spot, I'm going to write torque. And the units for torque, since it is force times distance, it's going to be Newton meters. If you look at this FD, force times distance, that might look familiar to you. Force times distance is also the formula for work. But the difference here is the force is not necessarily going to go in the same direction as the distance. Right, so we're not measuring the distance that the force moves the object. The force will be applied at an angle and cause a rotation. With work, the force and the distance have to be in the same direction in order for it to count. Next thing we have over here, torque in. The amount of torque you put in is going to be the same as you get out. And if you glance down here at the bottom, the sum of all torques equals 0 for a non-moving object. So if you're pushing on an object and it's not moving, it's not rotating, that net torque is going to equal 0. Looking down here, F in that formula is for force, which is newtons, and the distance, D, that is in meters. So torque is a vector quantity, so it will have a magnitude, and it'll also have a direction. We'll go into this more later this week or next week. So next we have MA. MA is our mechanical advantage. Okay, so you can look here, it's force out divided by force in, or distance in divided by distance out. So mechanical advantage is a ratio. All right, so it's not going to have units, but it is going to basically tell you how much benefit you get out of using whatever machine it is. Okay, so it's going to give you a ratio comparing the force you get out, so how much work the machine does compared to the force in, how much work you do. So F out is the output force. F in is the input force, or you can say it the force out of the machine and the force into the machine. We have our distance out, or output distance, and our distance in, our input distance. And last down here we have EFF, that is our efficiency. And efficiency is going to be another dimensionless. It's not going to have units measurement, but this time instead of measuring a comparison of the output force and input force, we're going to be dealing with work. So it's the amount of work done by the machine compared to the amount of work you have to do to get the machine to work. So the higher the efficiency means the more of the work that you put in gets put out on the machine. So those W's in and out are work. That again will be force times distance, but the force and the distance now would be in the same direction. And this is also something we will be going over a little more in depth later on. So if you scroll down here, types of simple machines. We went over a few of those in the videos yesterday. If you haven't gotten through those, take a look at those. The first one I'm going to go over is an inclined plane. So an inclined plane is basically a ramp. You have some we'll go over it later. We'll draw some pictures. I'll show you what the input and output are and where the work and forces come from. All right, next we have a lever. There are three types of lever. a first-class lever, something like a seesaw or a teeter-totter. We have a second-class lever, and a third-class lever. First-class lever, as I said, like a teeter-totter. Is that how you spell that? Or a seesaw. The basic key point is the fulcrum, or the pivot point is in the middle. Second class lever, this is something like a wheelbarrow. The fulcrum, actually we'll change that, we'll say the load is in the middle. So it will be in between your input force and, that's one word, in between the input force and your fulcrum. And the third class lever, this is like a lot of sports equipment, like a baseball bat or a hockey stick or a broom. And this is one where your input force is in the middle. So your fulcrum would be your hand on the top holding the broom. Your input force is down somewhere in the middle of the broom doing all the pushing. And then at the other end of the broom where the sweeping is happening, that is your output force. The next simple machine is a wheel and axle. And tied closely in with that one would be a pulley. I'll actually have to move the blade in here to number 5. Because there are 3 types of pulley. So the first type of pulley is a fixed pulley. An example of this would be attaching the wheel and axle to the ceiling, running a rope through it, and then you're able to lift objects by pulling down. The next type of pulley is a movable pulley. This is one where you would anchor the rope to the ceiling and attach the pulley to the object you're lifting, and then you would pull up to move the object up. And the third type of pulley is a compound pulley. This puts both types together. And again, we'll go into more of the types of pulley and go through examples of those later. Okay, the final 2, we have a wedge and we have a screw. So those are our 6 types of simple machine: inclined plane, lever, wheel and axle, wedge, pulley, and a screw. So if you scroll down a little bit further, we still have our I can checklist. Make sure you can do all those things by the end of the chapter. You watch the Khan Academy videos on Mechanical Advantage, and I just posted one about torque. You can take some notes here. And now, levers and torque, you should be able to do some of these homework problems. So look through these, start working on some of them. If you have any questions on any of them, let me know, and I will make sure I make review videos about those to post for you guys. If I don't hear back from you, I will choose 1 or 2 randomly and start going over those. Okay, so there are your homework problems. A lot of it's pretty straightforward. Read the question, but again, if you have questions, let me know. Have a great rest of your day.